Hi there, I'm Eric Knorr, Editor-in-Chief of IDG Communications, and welcome to True Technologist, where we talk with creators of groundbreaking enterprise technology. And with me today is Brendan Eich, the creator of JavaScript, arguably the most popular programming language in the world, and also the creator of the Brave browser, which blocks web ads and web tracking. Brendan, you were the founder of Mozilla, I believe?
Along with others, Jamie Zawinski, notably.
Right.
Yeah.
And you left the company 3 years ago to start Brave Software, is that correct?
Coming up on 4 years, past 4 years actually. Yes, past 4 years. Brave is about not just blocking ads and trackers, but giving users control of the data that's safeguarded by blocking those trackers.
Great. We'll get into that, but let's start with JavaScript. And thanks very much for talking about technology that's 25 years old. But
23, but close enough.
23, yeah, close enough. All right. So go in the Wayback Machine. Tell us why you thought there was a need for JavaScript to begin with.
Sure. So I was at Silicon Graphics in the 80s, and I knew a lot of the people who founded Netscape. Jim Clark, of course, was the founder of SGI and Netscape. And I was invited to join at the beginning, which I didn't, because I was sticking with a previous startup for another year. And then when I came in the second year, in April of 1995, I was lured with this idea of doing a very popular with academics language called Scheme. And it's a dynamic Lisp-like language. It has some nice properties, and it's minimal. Scheme in the browser. The idea was come and do Scheme in Netscape. Put this programming language into the browser. By the time that I joined in April, that story had changed because Netscape was doing a deal with Sun Microsystems, which owned Java, which they'd unveiled, which had been incubated for 5 years under a different name. And suddenly the story was, well, we don't know if we want Scheme. We don't know if we even need a little language like we wanted you to do. Maybe Java's enough. But Mark Andreessen of Netscape, Bill Joy of Sun, and myself, and a few others saw that there was a need for a language that was approachable, that you could put directly in the web page. Anybody could write or copy and paste. It was more like the BASIC or Visual Basic, Microsoft dialect of BASIC, that was popular in the Microsoft stack, that was used by millions of people compared to a language like C++ or Java, which is more for the expert programmers, right. Hundreds of thousands at the time in population. So 2 languages, one for people not as high up the programming pyramid. Maybe they were designers, maybe they were CPAs who learned how to program starting from Excel formulas and just branched out. And one that was for really the component authors, the expert programmers who knew how to write Java code.
Right, and Java and JavaScript having no relation has been the source of confusion for decades.
It was a marketing scam. And when we first did it, it was still under this cloud of skepticism. Do we need 2 languages? What will Sun think? But Bill Joy was stalwart. I did a prototype under Mark's code name Mocha. It was done in 10 days, notoriously, where I didn't sleep much. And then after I did it, I started embedding it into the Netscape browser, and immediately early users said, can you change this, can you change that? And I made some changes, which I regret. But it was so soon on a rocket toward shipping that I couldn't change much after a time. Mm-hmm. And so early mistakes and design decisions were frozen, and I was busy trying to make the rest of the browser appear as a set of objects in the language you could play with. And then it shipped. And it went through a name change from Mocha, which was just a code name, to LiveScript, because somebody in Netscape marketing liked the live prefix, LiveWire, LiveScript. And then the real goal all along with at least Mark and Bill was to make it the sidekick language to Java. So in December of 1995, it was renamed JavaScript with a trademark license that Sun gave to Netscape.
Right. So were you surprised at the way it took off?
I was a little concerned because it was this rush job of me working 10 days straight without much sleep. It was underfunded compared to Java, which had big teams at Sun and even Netscape, because it was hard to make Java work in the mid-90s on an average PC or a Windows 3.1 machine for sure. So JavaScript was underfunded. It was the sidekick. You could treat it like Robin to Batman and kind of not worry about it. And that's how it was treated. So when it started getting early traction, in spite of all the bugs and rush job aspects, I was a little surprised, but I wasn't shocked, because on reflection, what happened was the people who wrote the web page could now program the web page. Mm-hmm. With Java, you're writing this separate program that's kind of a bigger assembly that has to type check and have all these other sort of formal properties. And when you have it draw a picture, it can only draw in a rectangle in the web page. It can't directly interact with the forms and the paragraphs and the links. JavaScript, because I embedded it directly in the browser, could interact directly with the forms and the paragraphs and the links, eventually the images in Netscape 3, and then the rest is history. The whole document object model evolved from what I did. So what made JavaScript so powerful with all the warts and rush job properties was that it was directly connected to all the things in the browser that average web developers wanted to use. And that meant there were compelling demos, even in 1995 and 96. There's one on the Internet Archive, the web archive, you can find that mostly works. It's a catalog of art from Western artists in Idaho. And you can click around in it. Some of the images are missing, the art is missing, but you can see it working, and it's all JavaScript. It's all running in the browser.
How about that? So you mentioned certain things were rushed, and didn't have a chance to address those things before it shipped initially. Looking back, what would you have done differently?
So people will say, well, you should have said no, you should have noped out of there, as the kids say. You should have refused to work on such a short schedule by yourself. You should have taken my favorite language. The canonical placeholder name is Blub. I love Blub. Why didn't you use Blub? Well, it turns out Blub, if it was Perl or Python or Scheme, there were several implementations. None of them was actually ready for being embedded in a browser. They were all kind of running on your computer, not from a web page. They were giving code that you trusted, that you wrote yourself usually, and they weren't necessarily even safe in some computer science sense that's important for the code you load from a web page to be safe. So JavaScript from the beginning was a very safe model, even with all the bugs. It was by construction less risky, and I could do that directly even in 10 days. So what I would do differently is not take some existing language. I would have avoided some of the compromises I made when I first got early adopters and they said, can you change this? One of the notorious ones was, I'd like to compare a number to a string that contains that numeral. And I don't want to have to change my code to convert the string to a number or the number to a string. I just want it to work. Can you please make the the equals operator just say, oh, this looks like 2 and this looks like a string containing the number 2. They're equal enough. And I did it. And that's a big regret because that breaks an important mathematical property, the equivalence relation property. And it was not totally unknown. Other languages had similar sort of warts. And it led to the addition of a second kind of equality operator when we standardized JavaScript. And the funny story was, one of the people who helped us standardize JavaScript was Guy Steele, one of the co-creators of Scheme, that beautiful research language that I was tempted with that I couldn't have used when I got to Netscape. And Guy said, don't worry about it. There are lists that have 5 kinds of equal operators. We'll just add another one. So that was a little bit of a relief.
Well, I'm sure there are probably other things as well that you might want to change. How do you feel about the way package management has evolved with JavaScript?
JavaScript was so bare bones that you could just put a script in a web page. And then Netscape 3, you could load a script remotely, which is, by the way, one of the foundational pieces of web advertising as well as publishing, is scripts you can load from other sites. That was not what I would call a proper module system. And it took not only the monopoly collapse of the browser market and the revival with Firefox and then Chrome, but a lot of work in the JavaScript standards body leading into the current decade to make a proper module system for the standard version of JavaScript, which we have now, which is nice. So JavaScript's grown quite a bit. So when you look at what I did in 10 days, it was like a seed. It was this potent, kind of compromised but still very powerful kernel that grew into a bigger language. And part of the challenge, and I've been working on the standardization ever since I had to restart the standards body after we restarted the browser market with Firefox, I had to help people see how to let the seed unfold into a full language. And what should that module system be and how should it work? Independently, JavaScript grew popular on the server side through a project called Node.js. Node.js has its own module system, so a lot of the challenge with the standard module system was reconciling the two, making them work together as much as possible without doing things that don't work in the browser, even though they work in Node. Node's on the server, it has a different set of runtime semantics.
Were you particularly surprised by the emergence of Node, the server side
It's funny, I wasn't, because Netscape had a server-side JavaScript, and that's one of the reasons that I did this 10 days of work in a form that was like an engine you could put in the browser or in the server, because Netscape put it in a product called Livewire, which was like a PHP-like early application server. You could hit a database, get some results, put them through a template, and generate some HTML forms from them, for instance. That Livewire embedding of JavaScript and the people who were developing it led to some of these compromises, like the equals operator. But water under the bridge. The thing that did surprise me about Node was when it happened in 2009, it was really due to one person, Ryan Dahl, who was in love with the same things I loved when I was a young programmer, C and Unix. And Ryan really wanted to make a sort of dynamic language that had the flavor of C, but had sort of the asynchronous I/O that modern Unix had evolved. And he did that, and it was a huge hit, of course.
Right. So what do you think of the importance of TypeScript and its evolution so far?
So I'm a fan of Anders Hellsberg. I think TypeScript is a huge success for Microsoft. You cannot exaggerate it. It is one of those things that people wish we could standardize as such, but I think even Microsoft now views it more as, we have a community that uses this. We could try to standardize it, but it might be better just to let it be our thing, and we're always going to try to harmonize it with the evolving JavaScript standard, and that's a good thing. People don't necessarily know this, but JavaScript programs are TypeScript programs. All the types are optional and they're checked at tool time. That's another brilliant thing that allows you to start from JavaScript and start adding types that you can check when you're developing your code, but they all get erased and it just turns into JavaScript again when it runs in the browser. So, there are other projects like that. There were earlier ideas along those lines. There's more, I would say, more advanced type system implemented by Flow from Facebook. But these are all very good, worthy projects that in some ways are running large-scale experiments on real programmers. And the results can be fed back into the JavaScript standard. So we hope TypeScript and Flow and other such experiments will lead to some kind of optional type support in JavaScript down the road. It'll take more time. It'll take some work to sort of find the common intersection among these type systems, or find something else that helps them be more efficient, and we'll put it in the language.
Great. So what about WebAssembly? How do you see that affecting the trajectory of JavaScript, and how that might affect the way JavaScript evolves, say, over the next 5 years?
I should talk about how it happened, because the funny story there is there was this very potent seed that was the original JavaScript from 10 Days in May 1995. And part of it, based on lineage from the C programming language, but also from Java, was a set of arithmetic operators that resulted in or operated on integers instead of JavaScript's number type, which is a floating point binary number type. So people don't realize this, but JavaScript had integers kind of hidden away in the operands and results of these operators. These were bitwise and shift operators, if you know what those are. And those operators were key to ASM.js, this subset of JavaScript being developed at Mozilla 2012 on, based on some earlier work, I would say, sort of a parallel evolution at Adobe Labs, and then somebody at Mozilla in his side project was doing a compiler from C++ code or C code to JavaScript, and he started finding very fast idioms in JavaScript that he could generate from the C code, and suddenly he was running real like physics engines or SQLite, these impressive C programs in JavaScript in the browser, and if they were game engines, they were running at full frame rate. That led to the sort of formalization of ASM.js as a statically typed subset of JavaScript. When I say statically typed, people think, well, doesn't it have to have declarations for the types like Java does? It doesn't. Instead, it has these operators I added being used as sort of coercions at key points in the control flow and data flow, and that means that you can type check it, and you end up with something that runs like machine code, like assembly code, hence the name WebAssembly, ASM.js. That plus having a memory model that came from WebGL, another Mozilla innovation, was key to making performance deterministic. So WebGL had these typed arrays, which were just linear arrays of machine types. And if you didn't have those, you didn't have fast memory, you had the sort of garbage collected memory that JavaScript uses. If you have those, you can then project your entire C program's static memory and its heap onto that, and everything can be made super fast. And so that's what ASM.js did. And the funny thing was, at the time, the politics among the browsers was such that I would say mainly Google, didn't want to do something like WebAssembly or JavaScript as a fast machine target language for compilers. They wanted to do separate projects they'd acquired over the years, like the native client, portable native client, or they had this Dart project, which they still use, but which at the time they were hoping would replace JavaScript, which is, a fat chance. But over time, it became clear that ASM.js as this sort of kernel static language inside JavaScript could go as fast as the native client approach. And that led to WebAssembly. It led to the 4 browser vendors, starting with Mozilla and then Microsoft, where I actually talked to Anders and Steve Luco, who ran their JavaScript engine team in 2013. And then Google, which came around, and Apple all saying, yeah, let's do WebAssembly. WebAssembly is a separate language from JavaScript, but both are source languages for the same one engine in your browser. This is a key point because in the native client case, or in other cases like the Flash player, you'd end up with 2 engines. You'd have the JavaScript engine and the Flash engine, or you'd have the JavaScript engine and the Dart engine, or the native client runtime. And then you have 2 problems. Now you've got not just different engines to maintain, you've got the possibility that their memory regions can address each other. And if they do, their garbage collectors need to be aware of each other, otherwise they can form knots that cannot be collected. That was such a problem that it would require either unifying the memory management or having a sort of super collector that sits above the 2 garbage collectors and has an intrinsic cost. And somebody at Apple said, this cost will be measurable. It'll be a 5% performance hit on benchmarks. We cannot accept this. And that helped, in the WebKit project, prevent some of the hooks needed for Dart, I believe, at the time, to be integrated. And it led to this realization that JavaScript really is the one engine you need. But you can have 2 languages. The old language I did with the curly braces and the functions and the shift operators, and this new language, which is a binary language, not meant for reading by humans or writing, but can be generated by compilers and tools, can be read by tools, and that's WebAssembly. And since we already did it with ASM.js, now you'll find Unity games that are wholly cross-compiled from C++ to WebAssembly, and they run just as good in a browser.
And don't you think the inevitable effect will be that JavaScript itself does eventually sort of fade?
I speculated on this on Twitter, and people sometimes troll me as if I care. I think that could happen. It's very hard to do it on a predictable timeline because JavaScript was always this very fast loading. You could just write a snippet in the middle of your HTML. Right. Whereas WebAssembly wants to be these bigger modules that you can statically check all the types and then turn them into machine code very quickly. And I think what will happen is you'll have WebAssembly for the modules that you want to be doing machine code level performance tricks, or maybe some APIs that we don't surface to JavaScript. We only put in the virtual machine for the WebAssembly source language. There's already such APIs for things like vector instructions that you find on your CPUs these days. That means that WebAssembly will become more expressive over time than JavaScript. JavaScript will endure as long as it's the fast loading go-to and it's the way of dealing with all the browsers that are out there. If over time WebAssembly grows all these features that let it do garbage collection of the guest code that's being loaded and dynamic method calls that are very efficient like JavaScript engines do, which isn't currently in the WebAssembly state of the art but is on the roadmap, and a few other things that are on the roadmap, that will take years to go through, but it could lead to a point where you have a JavaScript engine that's loaded as a WebAssembly module. And that might be the way you get JavaScript. I still think it's going to be hard to wean the web off JavaScript because it's right there in the browser. You get very fast start. If you have to load this JavaScript engine as a module, it's going to be slower.
And you have the transparency of it and everything.
The transparency issue. There's a teaching issue. So it's hard, like I said on Twitter, there's no definite timeline on which WebAssembly will say, here's the flag day, and JavaScript's now just one of n modules you load. But never say never.
Right. Well, thanks very much for that. And now let's sort of change tracks here to go for Brave software. So the Brave browser blocks display ads and tracking, and that upends the business model of my company, among many others. That rely on advertising to support our content. So why do you see this as a good thing?
So I started Brave. I think this is important for any entrepreneur to start a project that means something to you, both as a user. I was annoyed by ads and tracking, but also if you have a larger point of view on the ecosystem. maybe an ecological point of view. Like there are advertisers who put money into this system and it flows through the ecosystem and some of it gets to the publisher. But where does a lot of it go? Sometimes more than 50%. It goes to all the intermediaries, the middle players, the middlemen, Mark said to cut out, right? That are taking a cut as they pass the funds along because they're promising to find the very best ad for this spot or track you as a user and realize when you get to the publisher site, you're ready for that Ford truck ad or that toothpaste ad. Now, you and I both know that this system is not very precise. I get ads that I don't want. I buy something and then I get an ad for it right after I come back from the store, yeah. I make the slightest motion toward a car site and suddenly I'm an auto intender and I'm getting car ads everywhere. So the system is not efficient. It is also a gateway to fraud and malware. This is an unfortunate truth, but the people putting money into the system, the CMOs, the brands, the marketers, they generally have to spend money. They will get fired for not spending it more than for spending too much. And so fraud is actually a concern to them, but not as much as it is to, I think, the publishers from whom the fraud cost is clawed back, sort of like the merchants get the credit card fraud laid on them. So we see inefficiency tolerated by one end of the system and not easy to tolerate by the other, where it does hurt. And we see malware coming into the system because if you can target users with a system to show them an ad, you can target users to put some ransomware demanding Bitcoin from your grandparents on the PC. And that's a real problem. It's a global criminal industry of size. Not sure of the exact dollar amounts, but this is being studied by people at the antivirus companies. Even Google has done some great research on this.
Right. So basically you've proposed an alternative advertising platform. Is that correct?
Yes. So if you take the ecological view, as a user, you should defend yourself. You don't want malware. You don't want ransomware. You should also, though, care about publishers that you prefer. And if you're blocking their ads with a regular ad blocker, there's not much you can do. You might get a dialogue from some of them saying, "We noticed you're running an ad blocker. Would you please whitelist our site or pay to subscribe, or maybe you can buy a little subscription or just buy an article." I understand those have pretty low conversion rates because people just don't want to open their credit card with thousands of websites they may go to over a month. What we try to do with Brave is, first of all, reconnect the valid parts of the ecosystem that we think need to be there because most people expect a free web. And that is the advertisers that are putting that money in, whether it goes anywhere good, and the publishers who need it to keep the lights on, and the user whose attention it depends on. So we try to cut out all the middle players, but keep the user, the advertiser, and the publisher connected. And the simplest thing we started with is not even the advertiser. It's if the user uses Brave, you have a private ledger, we call it. It's on your device only, it's in your browser. We don't see it on our servers. And it keeps track, if you choose to turn it on, of how long you've been at each site and how many times you visited it. And this kind of analytics is used in the ad industry and the site analytics industry. So you have this sort of private version of those analytics, like a Chartbeats in the browser. And then if you wish to, or if we give you a grant, which we have the ability to do, of tokens, you can start to set a monthly budget and have those funds just trickle out pro rata based on your browsing. If you see a site you don't like, you can turn it off. If you see a site you want to support with 10% or 20% of your budget, irrespective of whether you browse there, you can pin the percentage of your monthly budget. And since we're giving out tokens, and we have a lot of them that we pre-created that floated alongside the token sale we did last year, we are in a long-term mode of paying users to browse. We want to give users funds to compensate them for trying this model, to reward them for their attention, and over time, if they're willing, give them the other leg of the triangle, which is the ad leg. If they opt into the ad leg, it's not like ads as you know them. We can't suddenly, as an ad blocker and a tracker blocker, say, oh, you know what, we're going to throw you to the wolves and have you tracked in order to have you served an ad on the toothpaste you don't buy or you already bought. Instead, we want to do all the ad matching on device, just like the private analytics. In some ways, you could see Brave and the basic attention token that we've created as a new platform that turns the whole world of Google and all the trackers on its head. Instead of giving your cookie and your identifier and lots of signals out to the world, we try to protect the data and block the trackers that read those signals so that you can match ads on your device. You can decide to donate automatically based on your browsing. The ad matching being on device has some nice properties. It means that you get a catalog of, let's call them offers. It's like a a URL or a web address for the creative component of the ad and some keywords about the ad.
And the ads would go through you, through Brave? Or?
They would go through the browser, but not through our server. We wouldn't see them. They would come from various edge caches where they already live for the brands that are advertising. So we don't want to have that fingerprint, that list of your favorite sites. We don't want it when you do the donations or the grants that trickle back. We don't want it with the ads. We believe in can't be evil, not don't be evil. This is one of those catchphrases we're leaning into because thanks to cryptography and zero-knowledge proofs in particular, which are almost magical, we can do things like be sure we have an authentic user, but not know who they are and not have any link between that user and the contribution they make to a given website or the action they make on a given ad. And it turns out in advertising, what the brands want at the end of the month, 30 days, is a report on how many impressions or clicks or quartiles of video are viewed or conversion at the end of the video to download an app. They want those numbers in aggregate. They don't need to know about every individual person. They might like to, but they don't need to. And generally, to see if the ad performed, they want to say, did the person go a step further and buy something?
Right.
We can do that kind of attribution on your device and not send it out anywhere except in a sort of a blind summary form. And that's what the zero-knowledge proofs help us do. So we're trying to take not only the necessary parts of the ecosystem, the advertisers and the publishers and the user, into the new platform with the basic attention token. We're also trying to blind ourselves as a company and as a set of servers we run, blind the blockchain where you, it's a public ledger. Blockchain, you could put anything on it and it could identify you. We don't want that either. But allow the system to function in spite of the lack of individual personal identifiable information.
So you mentioned blockchain, and as I understand, just this week, a trial was announced. Is that correct with Dow Jones?
Yes. So we had Dow Jones Media Group and Brave announced that we're going to be giving out free subscriptions to Barron's and MarketWatch. We're also going to be doing experiments with the basic attention token on a go-forward basis. So this is really good news because obviously it's a great publisher of note, one of the top 3 in New York. And there's more to do as we prove the model. So having a partner like Dow Jones Media Group just unlocks a lot of future doors. Right. It means that we will be working always with our users choosing to participate. We're not going to turn this on them. That's another point that is becoming critical because of what's called the General Data Protection Regulations in Europe, the GDPR. Right. So Brave by default is just an ad blocking, tracking protection, anti-fingerprinting browser. We don't look at you, we don't turn on these features I mentioned. Even if you choose these features, which you have to opt into as a user, we don't see you on our server. We blind ourselves with these techniques I mentioned. But our baseline is just protective. So getting users to consent is extremely valuable. We think users should therefore get a slice of the revenue, which we're going to do. We think that gives us a very authentic, valuable user base. A lot of these users are off the grid already thanks to ad blocking. They came to Brave from, maybe they're using Chrome with a good ad blocker like uBlock Origin. Now they're using Brave, and they are still valuable consumers and producers. They often are creative people. They often are blessed with discretionary income, so they buy online. They do a lot of good searching in e-commerce. If you think about the browser, it sees all your searches. It sees all your Amazon buys. It sees when you're going from work to pick up your kid or go shopping. That's a set of signals that can be analyzed locally. So this ad matching I mentioned is an entirely local machine learning process. So since we're open source, you could audit it. We will have people with bounties that are awarded to people who prove there's a problem in it. We will fix the problem and we will give them a bounty if they show us a hole or an information leak. But this is a new model that tries to keep your data defended on your devices. And we can do multiple devices. This is something browsers have grown over the years. You have a laptop, you have a smartphone. Chrome came to iOS in 2011 and people said, well, Apple's kind of controlling. Are you sure you can do a good job with Chrome there? And Google was smart. They said, no, people love to share their bookmarks if they are bookmarkers. Or they love to see their browser history. Or maybe they can fling a tab from their desktop to their phone. Right. So those are reasons why browsers has developed a cross-device, what's called a sync for synchronization feature. And we have that too, but we do it in a way, again, that blinds us to your data. You encrypt it with your key on your device. You pair your key with a QR code and camera. That data, nevertheless, can be the sum total of your activity across your phone and your laptop. Right. That's also valuable.
Right. So So far, the web publishing industry has not been a fan. There was a cease and desist letter you got about a year ago from
2 years, and they were
2 years ago.
It was so
okay.
funny because the letter was called cease and desist.pdf in the file name, but they realized we weren't doing anything. We were just talking about ideas, so they removed the word cease and desist from the text of the letter.
Okay.
These are the kind of it was definitely a warning shot, and it was one of those things that you look back and laugh at because they said things like, we weren't sure if they were trying to trick us into taking a misstep. They said, "How dare you infringe our copyright and trademark by replacing our ads?" And my first thought was, the month before, the New York Times and BBC Online and AOL had malware, this ransomware, in third-party ads on these prestigious sites. So it's not your ad, or else you have liability for the malware. You don't hold copyright on the malware. So it was very clear. It was a teaching moment, but we're way past that now. I think what I've noticed talking to publishers since really the last 4 years is they might initially feel, and there's some institutional memory of this, that ad blockers are our enemy, and I wish ad blocking would just stop, and ad blocking is wrong, it's morally wrong. To, ad blocking is not going away, what can I do? Maybe I can get some kind of countermeasure or some dialogue that says, please subscribe, or please whitelist our site in your ad blocker. To, and that was 2 years ago, to, we're in trouble. Google and Facebook are eating up all the incremental ad spend. They're kind of first parties of note as well as third parties. So they're trackers and they're publishers. They have big sites. They kind of absorb our content into their instant articles and their AMP search proxy. We're being commodified. We better do something new. Maybe we're ready to innovate. Maybe we can try something with Brave too. This year, GDPR is about to be in force in May, on the 25th.
That's right.
It's not just Europe. Tourists in Europe are protected by it. It's like California emission laws. You didn't have California cars and the rest of America, rest of North America cars. The car makers realized it didn't make sense, and they made all cars meet the California standards. I think the same thing is happening with GDPR, and we're in the early days yet because there's still a lot of wiggling and squirming by some of the big superpowers to say, I don't need to change, or I'm already ready for GDPR. And GDPR has this principle of consent I mentioned with respect to Brave, that you can't track people without their, quote, informed consent. And if the list of trackers that a publisher uses is as long as your arm and you've never heard of these companies, you're not going to consent, or you can't truly be informed because some of these are data arbitrageurs and they're not trustworthy. So generally, if consent is required, users click no. At that point, maybe 80% of users say no in Europe, and the tracking audience, the forecasting audience for ad buying using automated methods kind of disappears. That means that advertisers will use other techniques. They'll use direct deals, they'll use contextual advertising, and they'll use deals where the publisher has a better relationship with the user and can get consent with a very short list of trusted partners. And that will be healthier. With Brave, we can do consent in the browser. We don't see your data on our servers. We're not tracking you. We think that we're GDPR ready, but we're going to actually go through the full audit and formalization of that to prove it.
So as part of what you're saying, Brent, is, I mean, as you say, Google and Facebook, they have, depending on what numbers you see, 60, 70% of, web advertising.
I hear 80, and then of the incremental growth from 2017 above 2016, some people say 90, some people say 99. You hear these numbers, so a lot.
So, when publishers like me hear about, about this technology, the instinct is what, you want to destroy your business, right? But you're saying there's actually a possibility of throwing some of that money back from Google and Facebook directly to the publisher.
Yes, let me say how that works. First of all, Brave is a small browser. We're not going to corner the market soon. So you can think of us as found money, because our users were previously using an ad blocker and there was no easy way for them to automatically and anonymously support their favorite publishers. We've created it now. So some of them using Brave are taking grants from us. Some of them have been funding their user wallet from their own credit card. And they're able to give back already where they were just blocking before. So that's a positive sum game. And you wouldn't turn these users into non-blocking users. These are diehard ad blocker fans. But if we get this private ad model, this private and anonymous ad model stood up, we can give 70% of the gross revenue to the publisher or to the owner of the ad slot, which for the user could be the user if there's a private tab. For the publisher, 70% is better than they're making off their ad partners today. I've talked to many publishers over the years. They all say, well, the programmatic doesn't pay me too well. They always say they're paying me 55%, but when I subtract all the costs, it's lower. Then some of them are big enough to do what's called direct sales. They have premium inventory for ads, like a fashion site like Elle.com. Elle has beautiful custom video creatives on the bottom half of its front page above the fold. They can do a good direct deal. Louis Vuitton handbag, there it is, it's great. And you can click through the videos and buy a handbag if you want to. But that direct sold ad took a sales force, it took some custom ad serving and click tracking, it took some IT work. So there's no free lunch. If you're doing direct sales, you're making a higher margin, but your costs have gone up on that basis too. And therefore, we feel 70%, it's kind of the App Store industry standard, 70% to the publisher is a very good rate, and we'll stick by that. We're not going to play games with the money like a lot of the ad tech players do. We're going to be very clean, and the blockchain lets us prove this by letting people audit the sort of macroscopic flows.
Right, right. So that's another side of the openness of what you're talking about as well.
Yes. Open source and blockchain, you just have greater ability for a third party, skeptic, somebody in a different jurisdiction to look and say, this is not cheating, there's no embezzling, there's no hiding the ball.
Right. Well, obviously this is something of great interest to us, and hearing about how this may affect the business model is fascinating for me personally. Great. And I'm sure there's lots of evangelizing for you to do in the industry. I'm sure it's the publishing industry. It's probably not very well understood at this point.
We start with the users. If we get enough users, the publishers will come. The advertisers are always game for a new audience and a new trial, and to appear that they're aware of ad blocking and GDPR. They're always willing, I think.
Well, great. Well, thank you for talking with us about Brave Software and doing the Wayback thing with JavaScript. Really appreciate it.
It's something I'm happy to do, and it all does connect because JavaScript formed one of those fundamental pieces used by the tracking and the ads that we block. So I'm making up for it.
All right. Thank you very much, and thank you for joining us.